Dates. Today we're going to be talking about Pythagorean's theorem. So Pythagorean was, an ancient Greek philosopher. Back then, all mathematicians, scientists, if you will, were called philosophers because math and science is all about explaining the world around us, and, so is philosophy. And so Pythagorean came up with a way to find the missing side of a shape. The way he did that is, if I show you in the presenter here, let's see. So if I have a triangle, such as this, that's not very straight, is it? If I have a right-angled triangle, such as this, and we have a right angle here, this is what we call the hypotenuse. The hypotenuse is the opposite of a right angle. But what Pythagorean found was this interesting correlation, relationship between sizes. So if I know these two sides of a triangle, I should be able to find this side. And if I know this and this side, I should be able to find that side. If I know this and this side, I should be able to find that side. It's kind of an algebra thing. Now, it's one of the first things in the textbook that's covered, but I often don't cover it in fall because I want us to get our feet wet with algebra first, and that usually comes closer to Christmas time. So that's why we spiral back. So let's take a look at Pythagorean's theorem. We're going to call this side A. We're going to call this side B, and we're going to call this side C. Now, what Pythagorean found was that A squared, like if I made a square with A as its root, and B squared, or a square that has B as its root, equals C squared. Because the area of this is A times itself, the area of this is B times itself, the area of this is C times itself. So, for example, let's say that A equals 4. Whoops, you can't see that. Hold on. Let's say A equals 4 and B equals 5, and we want to find out what C equals. Well, the formula here is that A squared plus B squared equals C squared. That's our formula. Well, I know A squared, so A squared would be 4 squared plus 5 squared equals C squared. Well, let's keep running with this. 4 squared is 16, 5 squared is 25, 16 plus 25 equals 36. Well, that means that C squared equals 36. Well, how do I get rid of that exponent? I'm going to go to the square root, and same to both sides, so it's balanced. Root versus squared cancels. The root of 36, that's what times itself, is 6. So what we've found, that when A is 4 and B is 5, since we know that A squared plus B squared equals C squared, we found C squared was 36. And if the area of this, it will say centimeters, is 36, then C, the area of one side, would equal 6. That is the main concept in a nutshell. But I mean, that's quick. I don't expect you to, watch a 3-minute thing and go, I've got it, right? So let's take a look at the assignment and start comparing. All right, so let's take a look here. We've got our two legs and the hypotenuse, just like we were showing in the initial part of this lesson. Let's go to an example here. Now this is almost exactly what I had shown you, except we had 4 and 3 here. And this talks about Pythagorean. This is a statue of Pythagorean, showing that we had one side, one leg was 3, one leg was 4. So the hypotenuse, or the opposite of the right angle, we were able to figure out is 5. And just to run this really quick on the board to review how to use the formula. So the formula is A squared plus B squared equals C squared. Here we have a triangle like this, and we have A, B, and C. Now, since we know that a squared is 16 and b squared is 9, we now have 16 plus 9 equals c squared. To back that up just a moment, we knew that a plus b squared equals c squared. We knew that a was 4. We knew that b was 3. So we have 16 plus 9 equals c squared. 16 plus 9 is 25. It's off the screen. And that equals c squared. To get rid of that little 2, we need the opposite of squared. The opposite of squared is root. And we are left with c equals 5. And that's the same as we have in the textbook right here. So let's take a look at this example right here. We have two legs that are 4 and 4. So if I've got, here we'll draw it like they have it, got the right angle. This is the hypotenuse. We know that side A is 4, side B is 4. So we have A squared plus B squared equals C squared. That's 16 plus 16, which equals 32. But here we have a conundrum. We are not going to get a clear answer because I can square this and I can square that. But the problem is, this is not a perfectly squared number. If I have 32 square blocks, I can't make a perfect square out of them. However, I can enter into my calculator a square root button. So I'm just going to open my calculator here. Let's take a look. There is my calculator. But I don't have a square root button. No worries. I'm just going to turn it sideways. And there I have a tiny little square root button. Square root of 32 equals, oy vey, is that ever long? 5.66 rounded up. It's not very clear, hold on. It's 5.66 rounded up. So I'm going to go 5.66. So my missing side here is 5.66 centimeters long. Well, let's look at example 2. Now, example 2 has it a little different. We now have A and B and C, but B is missing. Well, let's start with our formula and let's plug those values in. So I know my formula is a squared plus b squared equals c squared. I know what a is. A is 5. I don't know what b is, but I know what c is. C is 10. Well, 25 plus b squared equals 10 times 10 is 100. I can get rid of the 25 to get the b on its own. And now the opposite of squared is a root. But once again, that is not a perfectly square number. And when I put that into my calculator, it spits out this big, long number. But I think I'm just going to round that up to 2 points. Rounding up to the hundredths is good enough. And so there we have that b would be equal to 8.66 centimeters. So see my little hand here? We took a squared plus b squared equals c squared, but we had to balance the equation to find that b, this leg, was 8.66. And when I look at the picture, does it look about right? If this is 5, does that look about 8.66? Yep, that looks a bit reasonable to me, because I know this hypotenuse would be slightly longer. And I mean, that is basically what we're doing here. If you can take a squared plus b squared equals c squared, you're good to go. It's really just about balancing. The trickiest part is when you get to something squared equals a non-square number. For example, like right here, where we had b squared equals 75, and 75 is not a perfectly square number. But in that case, you just got to punch in the square root and then the number and get your big long decimal and round it to the nearest 100. And that's basically it. Now, as per usual, I don't expect that you will just, know it right off. I am in study hall. There's my son in the background. I'm in study hall, and I'm happy to help you out with whatever you need with these problems. This concept is kind of one of those, once you got it, you've got it good. So, let me know, because until you, get it and it clicks, it's difficult. But once you get it, you've got it good. All right. I hope to see you in study hall, and I look forward to working with all of you.